so let's, we have the graph. I'm trying to organize everything a little bit more. And actually I will start to give it title and whatnot. So this is creating louvers. It's always good to kind of keep things in order as you're developing them. And then I'm going to again address this Y. So I have this line and I'm going to evaluate it, because what I want to find out is this line here. And let me go ahead and turn off the loft. So this line here, I want to evaluate kind of its direction, and I'm going to move that to be perpendicular to its direction. So I'm going to go up to curve and I'm going to evaluate it. I'm going to evaluate it according to, oh no, I don't need to even do that. I'm actually going to use this information, one of these two pieces of information. Now they're not parallel, so I am going to kind of be I'll be using basically one of the lines as my reference point, and so so I'll have to decide kind of which one would be the best. I'm just going to use this top one. And as you recall from the last video, the divide actually gives you tangents. So the tangent for any of these points is kind of tangential to the direction that it's moving at that moment. So this being a straight line, we know that the tangent's kind of moving along the line perfectly. So I'm just going to use that, and I'm going to go up to vector. I'm going to use a rotate vector. Now I'll put the T into the vector. If I roll over this, I'll know that it's looking for vectors to rotate, and then the X is looking for a rotation axis, and then the rotation angle finally. So the rotation axis is actually rotating along this line. Well, I have that information here, so I'm just going to plug that in to the X, and then I'm going to give it a number. So I'm going to grab a panel, and assuming that I want to keep these kind of always at 90 degrees, I'll do that. Put in a number, 90, and we'll roll over the A, and it's looking for rotation angle. But notice that it says in radians. Now in radians means that we have to kind of convert an angle, a number, into radians. So there's a really simple way to do that. I'm just going to use the radians component, and essentially that will do the conversion for me. So 90 degrees is actually 0.5 times pi. Alright? You don't necessarily need to know that, but it's probably good to actually know how radians work. And I'll plug that in. And so now I should have a vector that's perpendicular to the points up here. So instead of using this Y, I'm going to use this V. Now the one thing that you have to remember is that this is a vector. It's moving in a certain direction, but it doesn't have a value as far as how much the force is, how long that it's going to move in that direction. So I'm going to add one more component. It's called Amplitude. The Amplitude allows you to plug in a vector. I'm going to delete this Y, and then give it a value. So I'm going to just plug in, say, 2, and just double click, hit 2. When you do that, you get automatically, if your numbers between 0 and 10, it'll give you a slider that is already set up for 0 to 10 with integers. If I double click and put like 0.25, it'll give me a slider that's set up between 0 and 1, and it gives you the hundredths place. If I go through anything above 10, say 11, it'll give me a slider set up for integers between 0 and 100. It's a pretty nice way to kind of get sliders set up automatically for you. So I'm going to draw this down to say 2, plug it into here. So now I have a direction and I have a force for that direction. I'm going to plug it into my move, Now let's turn the loft back on. Okay, so now if I did this right, I'm going to be able to rotate these lines in any direction, and it still works that they will be offset in the correct way. And realize that I can start to rebuild these, and if they were wanting to be slightly more complex geometry, because again I have relative information, not absolute, you can see that these louvers are then always kind of building perpendicular to that curve, specifically the top curve, because that's the one that I use for this vector information. If I plug it into here, we'll see that it dramatically changes, and it's now going to use this straight line. And so now that's the relationship. So again, I can kind of change things. I can also add one more thing. Try to get this information. This kind of drives you a bit crazy sometimes to create hairballs for yourself. So there's a few tools in Grasshopper that allow you to kind of align various pieces of your components, so you can kind of straighten them up and get them just right. So this, and then it's also good for them to start to label these. So this is depth of louver, and then I'm going to add one more thing. Let's say that I do want to rotate these in various angles and kind of check on sun shading and whatnot. So I'm going to go ahead and type in 30 and call this out as rotation angle for louvers. A little wordy, but that's good. And I'm going to plug that into the, instead of the 90 being my value, which is perfectly perpendicular, I'm going to plug it in here. So now I have rotation up to 100, and say I wanted a little bit more than that, say 150. I can look at this kind of being fully open or closed. Okay, and there's a lot of things that I could do to kind of make this more absolute, but this is addressing the major issues of creating louvers. Alright, great.